Hello friends, this is my second lecture for 11th standard physics unit number that is chapter number 1, second lecture, not lecture numbers 2, lecture number 2, units and measurement, okay. My previous lecture I completed what? The characteristics of what? Unit, different characteristics of requirement of good units, right? Today the system of units, start from the system of units. System of units. System of units. There are 4 types of system of units. What? First one is MKS, second one is CGS, third one is FPS, and fourth one is SI. Long form of a MKS system is what? Meter, kilogram, second. Meter, kilogram, second. CGS, centimeter, kilogram, second. FPS, foot, pound, second. And SI is a system of international, or what? International system. What? International system. In MK system, mass is measured in, length is measured in meter, mass is measured in kilogram, and time is measured in second. In CGS system, mass length is measured in centimeter, mass is measured in gram, this is a gram, and time is measured in second. FPS, that is foot, pound, second, that is length is measured in foot, mass is measured in pound, and time is measured in second. And this is the all over universe system, that is the system of international, right? This third system is used in British countries, right? Student, you all see the WWE Raw, the Roman ring, 275 pound, right? त्याच्यामध्ये वेट जे आहे ते वेट हे पाउंड मध्ये मोजलं जातं. काय केलं? वेट मस्ट बी मेजर्ड इन पाउंड, राईट? आणि दिस 11th international conference. 11th international conference, the all systems, all units are measured in a SI system. All units are measured in SI system. Student, you are known the what is the system of units or the types of system of units, which system, how they are used, okay? Complete student. Next part, it is a dimension. Next part, what is my dimension? What is the meaning of dimension? Dimension means what? Dimension means what? Ghat, akar, miti, that is the akarman, okay? And what is the exactly definition of the dimension? Dimension may be defined as it is powers to which to give a complete information of a given physical quantity given physical quantity is known as dimension. Is known as dimension. What is the dimension? It is a powers to which to give a complete information of a given physical quantity is known as the dimension, right? In present, in represent the dimension, the square bracket is used. Which bracket? Square bracket is used. The measure mass, letter capital M is used. To measure length, letter L is used. Measure time, letter T is used. Measure temperature, letter K is used because unit of temperature is Kelvin. Measure current, letter I is used. Letter I is used. This is the some letters are using to represent the dimension. Second definition is the dimensional equation. Dimensional equation. What is the dimensional equation? The equation in the form of LMT is known as dimensional equation. Is known as what? Dimensional equation. Is known as what? Dimensional equation. Student, I take it the detailed dimension, but before first write the definitions of dimension and dimensional equation. Then, student, find the dimension of different physical quantities. First one is the dimension of length. Dimension of length, right? In dimension of length, only length are involved. What? Dimension of length, only length are involved, right? To represent the dimension of length, L is to 1, M raised to 0, T raised to 0. Means what? In case of the dimension of length, only length are involved, right? That is, mass is 0 present, time is 0 present. Second, dimension of distance. Again, distance is nothing but the length. Then again, dimension of distance is the M raised to 0, L raised to 1, T raised to 0. तुम्ही पहिला M रिप्रेझेंट केलं चालतंय, L रिप्रेझेंट केलं चालतंय, T रिप्रेझेंट केलं जातंय. थर्ड, dimension of area. Dimension of area. Which is the formula of area? Area is equal to length into breadth. Length is the sum length and breadth is also same what? Length. Means what? L square, right? Means what? Dimension of area is equal to what? L square M raised to 0 T raised to 0, right? This is the dimension of area. Fourth, dimension of volume, which is the formula of volume? Length into breadth into that is L length is the length, breadth again is length, height is again is length, that is the L cube. Therefore what? Dimension of volume is equal to L cube. That is the dimension of volume is equal to L raised to cube m raised to 0 t raised to 0. This is the dimension of what? Volume, right? Next, dimension of density. Dimension of density. Density means what? Ghanta, right? Density means what? Ghanta. What is the formula for density? That is mass upon volume. Mass upon volume. That is dimension of density is equal to dimension of mass divided by dimension of volume. What is the dimension of mass? Dimension of density is equal to what? Dimension of mass, this is m raised to 1, and dimension of volume is what? L raised to cube, right? That is, which is the total dimension of density? Then the dimension of density is equal to m raised to 1 L raised to minus 3 t raised to 0, m raised to 1 L raised to minus 3 t raised to 0. This is the dimension of density. Sixth, dimension of velocity. Velocity, right? What is the formula of velocity? Velocity is equal to distance upon time. Means what? Dimension of velocity is equal to dimension of distance divided by dimension of time. That is, dimension of velocity is equal to dimension of distance, that is L raised to 1 divided by t raised to 1, that is total dimension of velocity is equal to L raised to 1 t raised to minus 1. L raised to 1 t raised to minus 1, right? Next, dimension of acceleration. Dimension of acceleration. Which is the formula of acceleration? Acceleration is equal to what? Velocity upon time. That is, dimension of acceleration is equal to dimension of velocity upon time. That is, dimension of acceleration is equal to dimension of velocity is what? L raised to 1 t raised to minus 1. Dimension of time is what? T raised to 1. That is the dimension of acceleration. Here t raised to 1 cannot work in, that is L raised to 1 t raised to minus 2, because this is the minus 1 into minus 1 is minus 2, right? This is the dimension of acceleration. 8, dimension of force. What is the formula of force? Force is equal to mass into acceleration, right? Means for dimension of force is equal to dimension of mass into dimension of acceleration. That is, dimension of force is equal to dimension of mass is the m raised to 1. Dimension of acceleration is the L raised to 1 t raised to minus 2. This is the total dimension of force is equal to m raised to 1 L raised to 1 t raised to minus 2. This is the dimension of what? Force. Okay, student completed some dimensions and I taking them again some dimensions. Next point, dimension of momentum. That is ninth dimension, dimension of momentum. Momentum denoted by letter P, which is the formula of momentum. Momentum is equal to mass into velocity. Mass into velocity. That is dimension of momentum is equal to dimension of mass into dimension of velocity. That is dimension of momentum, that is P, is equal to dimension of mass is m raised to 1 into dimension of velocity is l raised to 1 t raised to minus 1. This is the dimension of momentum is equal to what? M raised to 1, L raised to 1, T raised to minus 1, right? M raised to 1, L raised to 1, T raised to minus 1. This is the dimension of momentum P. Next, dimension of impulse, that is a J, which is a formula of impulse, that is impulse is equal to force into time. That is dimension of impulse is equal to dimension of force into dimension of time. That is impulse is denoted by letter J. That is dimension of force is equal to m raised to 1, l raised to 1, t raised to minus 2 into t raised to 1. That is dimension of impulse is equal to m raised to 1, l raised to 1, t raised to minus 1. This is the dimension of what? Impulse J. Right? Next, dimension of work or work done. What is the formula of work done? Work done is equal to force into distance. Force into distance. That is dimension of work done is equal to dimension of force into dimension of distance. That is dimension of work done is equal to dimension of force is m raised to 1, l raised to 1, t raised to minus 2 into dimension of distance is l raised to 1. This dimension of work done is equal to m raised to 1, l raised to 2, t raised to minus 2. This is the dimension of work done. Next, dimension of power. That is okay. Dimension of power, not represent a symbol. What is the power? Formula of power. Power is nothing but what? Work per unit time. वर्क पर युनिट टाइम, कार्य करण्याच्या दरात शक्ती असे, पॉवर मीन्स व्हॉट? शक्ती, दरात शक्ती असे म्हणतात. दॅट इज डायमेन्शन ऑफ पॉवर इज इक्वल टू डायमेन्शन ऑफ वर्क डिवाइडेड बाय डायमेन्शन ऑफ टाइम. दॅट इज डायमेन्शन ऑफ पॉवर is equal dimension of work is what? m raised to 1, l raised to 2, t raised to minus 2. Dimension of time is what? t raised to 1. Then which is the dimension of power? Is the m raised to 1, l raised to 2, t raised to minus 3, right? Because this is the upper sign, that is a minus here. The dimension of power is the m raised to 1, l raised to 2, t raised to minus 3, right? Next, dimension of potential energy. 13, dimension of potential energy. Potential energy. What is the formula of potential energy? mgh. M is what? Mass. That is m raised to 1. What is the g? G means what? Acceleration due to gravity, studied in the 10th standard. Dimension of g is equal to l raised to 1, t raised to minus 2. And dimension of height h is what? L raised to 1. That is the dimension of potential energy is equal to m raised to 1, l raised to 2, t raised to minus 2, right? This is the dimension of potential energy. Next, dimension of kinetic energy, which is the formula of kinetic energy, half mv square, right? Then the dimension of kinetic energy is equal to half, there is a number, there is no dimension, that is the dimension of mass into dimension of velocity bracket square, dimension of velocity bracket square. Then this is the dimension of mass, this is the m raised to 1, into dimension of velocity is what, l raised to 1 t raised to minus 1 bracket square, that is the m raised to 1 into l raised to 2 t raised to minus 2, that is m raised to 1 l raised to 2 t raised to minus 2. This is the dimension of what, kinetic energy. Students, see here, observe there, the dimension of this work done, dimension of this potential energy and dimension of kinetic energy is always same, because work done is nothing but the energy, work done is nothing but the energy. Student, I compare the total dimensions. Okay, again some dimensions are developed because formula is generated, dimensions is represented. Okay, but before student completes all these dimensions, again to the next the applications of the uses of these dimensions. Next point, the uses of dimensional analysis. What uses of or applications of dimensional analysis? Uses of dimensional analysis. Uses of dimensional analysis. The first use to find. The first use what, to find conversion factor, to find the conversion factor between same physical quantity, but different system of units, different system of units, right? Okay, and this there is first example, the force measured in SI system is Newton, the force measured in SI system is Newton and CGS system is dyne. The force measured in SI system is Newton and CGS system is dyne. CGS system is dyne. Then force is the same physical quantity, right? Measured in SI system is Newton and CGS system is dyne. And to find the conversion factor between what? Different system of units. That is what? Let M1, L1 and T1 are length, mass and time in SI system, okay, and M2, L2 and T2 are length, mass and time in CGS system respectively, right? आता आपल्याला काहीच त्यांचं रिलेशन माहिती नाही. मीन्स व्हॉट 1 Newton is equal to x time, right? This is the equation number 1, and to find this x is find out what this x is find out using a dimensional analysis. What? Using a dimensional analysis. Then taking dimension on both sides, that is dimension of Newton, right? Dimension of Newton is equal to x into dimension of dyne. Newton means what? Force in SI system. Dyne means what? Force in CG system. That is dimension of Newton means what? m1 is to 1, l1 is to 1, t1 is to minus 2, right? This because dimension of force is m raised to 1, a raised to 1, t raised to minus 2, right? Similarly is equal to x into dimension of dyne is what? m2 raised to 1, l2 raised to 1, t2 raised to minus 2, t2 raised to minus 2, right? Then find out the value of x is equal to what? X is equal to what? m1 raised to 1, l1 raised to 1, t1 raised to minus 2, right? Divided by m2 raised to 1, l2 raised to 1, t2 raised to minus 2. X is equal to, separate m1 upon m2 raised to 1 into l1 upon l2 raised to 1 into t1 upon t2 raised to minus 2. m1 is mass is measured in kg mk system, m2 is mass is measured in CG system. That is x is equal to kg upon gram raised to 1 into, this is a meter, this is a centimeter raised to 1, and 2 this is the second upon second raised to minus 2, right? X is equal to, then kg is converted to gram or gram is converted to the kilogram. Then this is 1 kg, that is 1 kg is equal to how many gram? That is the 1000 gram divided by gram raised to 1 into what? This is 1 meter is equal to 100 centimeter, that is 100 centimeter upon centimeter. This second upon second, this is 1 raised to minus 2, right? Student, this is power is to 1, this is again power is to 1. This gram gets cancelled, this cm gets cancelled. X is equal to, this is the 1000 and 2 this is the 100 into 1 raised to minus 2, 1 raised to minus 2 is the 1, that is the x is equal to what? This is the 10 raised to 3, this is the 10 raised to 2, that is x is equal to 10 raised to 5, x is equal to what? 10 raised to 5. Therefore, which is the relation occurs? That is 1 Newton is equal to x dyne, that is 10 raised to 5 dyne. Then this is the conversion factor between the same physical quantity of force in SI system and CGS system. SI system and not CGS system. Student, I similar take it another example, but before complete this example, first uses some dimension analysis. This is the second example of type of the same physical quantity but different system of units. Second example is what? Energy measured in SI system is joule and CGS system is dyne. Sorry, erg. CGS system is what? Erg. Then find the relation between joule and erg, right? Again same procedure here. 1 joule is x erg, right? Because this conversion factor is not known, okay, then consider it x, right? Let again L1, M1 and T1 are length, mass and time in SI system or MK system, right? And L2, M2 and T2 are length, mass and time in seizure system respectively, right? Seizure system respectively, okay? Then again 1 joule is equal to how many erg? That is x erg. This is the equation number 1, this is the equation number 1. Taking dimension on both sides, that is dimension of joule means what? That is the dimension of energy, dimension of work done, dimension of kinetic energy, dimension of potential is the same. And what is the dimension of joule? That is energy in SI system. M1 raised to 1, L1 raised to 2, T1 raised to minus 2, right? Again x is equal to what? M2 raised to 1, L2 raised to 2, T2 raised to minus 2, okay? That is what? Find out the x, that is conversion factor. This is M1 is to 1, L1 is to 2, T1 is to minus 2 divided by what? M2 raised to 1, L2 raised to 2, T2 raised to minus 2, okay? Then this x is equal to what? M1 upon M2 raised to 1 into what? L1 upon L2 raised to 2 into what? T1 upon T2 raised to minus 2, okay? That is x is equal to mass measured in SI system, that is a kg, mass measured in seizure system is a gram, bracket 1 into length measured in SI system is meter, seizure system is centimeter, bracket raised to 2, this is second upon second, bracket raised to 2. Again x is equal to 1 kg is how many gram? That is 1000 gram. This is again gram raised to 1 into what? This is 100 centimeter upon centimeter raised to 2 into s upon s, that is 1 raised to minus 2, right? Student, what? This centimeter get cancelled. X is equal to this 1000, that is a 10 raised to 3 into this is 1000, that is a 10 raised to 2 bracket square into 1 into 1 raised to minus 2, this is 1. X is equal to 10 raised to 3 into 10 raised to 2 square is equal to 10 raised to 4, that is x is equal to 10 raised to 7. Put in 1, that is 1 joule is equal to 10 raised to 7 erg, and this is the conversion. In lower class already studied in the conversion factor, that is 1 joule is equal to 10 raised to 7 erg. But this proof of this, what? Using a dimensional analysis. Student, I completed 2 examples of such type of to find the conversion factor between same physical quantity but different system unit. Continue this example.